Okay, yeah, I'm Mike Dresser. I had a long career as a research scientist. Had a lab over at OMRF and spent the whole career really writing code for different platforms using different languages just to help promote the research in the lab. For the last 10 years of that, mostly wrote C++ in Windows for visualization, data capture, and that kind of thing. I really like writing code. I always did. I went off to a startup, left the lab, went off to a startup, and then moved on from there. Decided about 3 years ago that I wanted to start developing mobile apps full time. It seemed like a really good challenge. It's exactly the sort of things that I like to do, and there's this thing of having a computer in your pocket that's just completely compelling to me. So that's where I went. I started off about 3 years ago learning Java and writing an app for Android. My daughter Emily, who's right here, wrote the iOS version of that. And in that experience of trying to keep two projects in sync and make them look similar enough on the two platforms so that it would be easier for users to go back and forth between the two, it got a little bit, not frustrating, but more work than I really wanted to do when I took on another project, write another app, where I could choose how I was going to do it. So this is about 1.5 years ago. Flutter had just hit the scene as Google's next attempt to develop a cross-platform SDK where you could write it in a single language, have a single code base, and have it run on iOS and on Android. So what I'm going to talk about today are sort of my experiences in that, or actually it builds on my experiences in that. What I'm actually going to talk about is sort of give you an introduction to Flutter, which means starting with the language that you use to write Flutter apps, which is Dart, to sort of set the stage for how Flutter has developed. Tell you some things about Flutter, go over some of the features of Flutter, what makes it different, what makes it better. I'll say outright that I'm a big advocate for the Flutter platform or Flutter SDK, and then actually get into a little bit of app architecture and a little bit of code so that you can sort of see what it all looks like. Okay. So the first thing is I have my IDE open here. You can see a little bit of the code, and I'm going to go ahead and launch the debugger. I've got a simulator set up here that I should be able to move around. There we go. So there it is. And I'm going to launch the debugger. And in about 20 seconds, it should fire up. And that's actually to make a point. How long does it take for it to recompile? There's nothing really to redo here, but also to get set up. In this case, this app, and sort of I've embedded my talk in an app that I just chose to illustrate some things that someone else wrote. Okay, before you're actually ready for it to go, okay? So I've done this a number of times, and it's usually 18 to 20 seconds before you're ready. So just briefly, what this app is about is to enter, I don't really mean to do that, an email address. You'll notice this is not much of an email address, and a password, okay, and submit that. And now, if I go to Firebase's Firestore, so this is actually a console for the web. What you'll see is that, actually I'd already done this before, that I've logged in, and you can see the information here. The idea of this app is to be able to write a list of goals for the year, to be able to share those with others to presumably hold you to those goals. And don't worry if you can't see this very well at the moment. Basically, I'm just going to add a new goal. Let's say give talk, and I would say something about it, okay, and submit it. And what you see is immediately it shows up in the Firestore data store, all right? And in fact, now I can go back, you can see it here, not very well maybe, and I can delete it from here, and it'll be deleted, in the cloud in the Firestore. Okay, so that's basically how this app is meant to work. And to those of you who are OCD as I am, I should apologize for the date at the top of this, but it's there for a reason. Okay, so now I'm going to make it possible for you to actually see, I hope. This is at a very awkward angle here to start making my points. Is that big enough that everybody can read the text okay? Anybody have a problem? Okay. So, January is a long month this year. I did that on purpose, I should say. First time I did it, I didn't do it on purpose, but I'll use that in just a second to make another point. Okay, so Dart. Many of you may have heard things about Dart that suggest to you that you don't want to use Dart, especially if you heard those things early on. Oh, and let me say this. I gave a talk that's similar to this and actually uses some of these points at the end of November to the functional programming group. Was anyone here for that talk? Okay. There will be a lot of differences between this and that talk because I knew that was coming. That was aimed more at functional programming. This is aimed at iOS developers. But there will be some similarities, obviously. Okay, so Dart. When Dart was first developed by Google, it was developed to be a JavaScript alternative. They were trying to compete with JavaScript. As a result, they developed the Dart virtual machine. Dart was just-in-time compiled. It was dynamically typed to be like JavaScript. And so it transpiled to JavaScript because, in fact, they were not winning that battle. And, in fact, they never did win that battle because JavaScript was already so well entrenched. So, essentially, Dart version 1 failed to gain market share and wasn't much used outside of Google. But when I first started doing my homework to decide whether I wanted to do Dart or not, use Flutter or not, it was clear that it was getting very popular within Google and not for reasons only that they worked for Google. That is to say, it's a very friendly, easy language to use. It was meant to be that way. That's what they were trying to do, was draw in developers, okay? So all this virtual machine and just-in-time compiling things didn't work out for them at the time, really, but turns out to be a real strength for where we are now, and I'll get to that. So version 2 was just released a few months ago. Version 2 is strongly typed. The compiler does type inference very well. Dart has futures, which if you use JavaScript, then you would know those as promises. It has async await keywords. I'm just going to blast through these so I can touch on them. It has generics, which is very handy. Has first-class functions. I'll show you an example of that. Streams are native to Dart. I'll do that. It has fast, really fast garbage collection. And that's critical because a goal of Flutter is to be able to sustain 60 frames per second, to have really smooth animations. And the claim is, and this was actually measured, so I think it's not ridiculous, but it was probably on pretty good hardware, that in that 16 milliseconds of time that you have between drawing frames in order to sustain 60 frames per second, that the garbage collector can collect 30,000 objects. Okay, so it's quick. And for anything that's not in Dart, there are code generators and there are libraries for extended functionality, and I'll touch on a little bit of that too. So when Flutter was released, they had a number of goals. One thing was to make it open source, and that is terrific because when you first set up to develop in Flutter, the first thing you do is clone their GitHub repo. So you have the source code on your machine. Obviously, when you're debugging, you can track things through there, but even more importantly, you can go to the code and look for the embedded comments because they've done an excellent job of explaining each and every step, why everything is there, have examples for how to use different classes and that sort of thing. It's like a game engine really. That is to say, it's different, and I'll show some diagrams here in a second. But it's not like React Native, for example. That is, it has its own engine for drawing on the screen or drawing on the canvas. And that means that it works equally well on fairly old versions of Android or of iOS as it does on the newest versions. Now, obviously, it benefits from better hardware, typically for the newer versions, but it's fairly remarkable how far back you can go. So here is sort of the typical architecture of the apps that most of us have been writing to this point. That is that you have the native code. So for iOS, obviously Swift or Objective-C, for Android, Java or Kotlin. And that talks directly to the OEM widgets, which give iOS and Android sort of their typical standard looks that then draw. And then to get to sensors, the camera, and all that sort of thing, when you're doing a native so-called app, then you can communicate more or less directly with those sensors, with the camera and so forth, or GPS. Flutter, now this is just the Flutter SDK. The whole Flutter framework is written in Dart, as I was saying. There are, in fact, material widgets and Cupertino widgets to give it an Android or an iOS look and feel. Okay? Those are built on just standard widgets, and all these things are incredibly easy to modify. It has a rendering tree that it builds from the widget tree. The rendering then actually handles the animation, painting, and gestures, and then there's the foundation, which largely is Dart UI, which talks to this lower level Skia engine for drawing on the screen, Dart, of course, and also it uses the Chrome engine for drawing text, I believe. That is to say, it's a well-developed, it's been around a long time. It's had a lot of developers look through it and use it and tweak it. So now, actually, I'm going to go back one step, because what normally I deal with in talking about Flutter is, well, why not just use React Native, right? So React Native is another cross-platform developing framework for JavaScript developers. And the difference between React Native and a native sort of app is here. Let's see, I don't know if that's going to work. That basically between the native code and between the platform, there's a bridge. And everything goes across that bridge. Now that means that you have access to the OEM widgets, right? The specific platform's widgets is going to look like that, but everything has to work back and forth across that bridge, and as a result, it's not as performant as a native app. All right. With Flutter, it looks like this. That is, the widgets and the rendering are with the native code. And it is native code. By the time you do a release, and I'll probably repeat myself on this, it's actually ahead of time compiled down to ARM binary code. Okay, so it's native. In order to do the drawing, then obviously it's just drawing on the platform's canvas, which also provides events. But in order to get to the services like camera and other sensors, then you have to go through platform channels. Platform channels, and basically then on the app side, you're writing in Dart. You marshal whatever data you need to across this channel, and then if for iOS, you would write in Swift or in Objective-C, Android, Java, or Kotlin, that then collects information from these services. Okay, so that part does go through a channel, but it's a very fast channel. Okay, so that's sort of the difference between Flutter and the basics of Flutter and React Native. Okay, so back to here. Again, the release version is ahead of time compiled, and that's why you can go as fast as you can go. All right. There are two things well, one thing in particular that makes developing in Flutter fun, especially for development of the UI. So I'm going to show you a hot restart, and in order to do that, in order rather, to fix this problem of January the 47th, okay? Now in Flutter, everything is a widget. And you probably can't see the names of these things over here, but this is the widget tree as looked at by the debugger. Even the app itself is a widget. Now what that means is, unless you're a leaf in the tree, you're a node, then you have a child, and obviously a parent that has put you into this tree to begin with, all right? So you can have these really deep trees. You might say, well, how are you going to find those things? So I clicked on basically what's a finder function, come back to January the 47th, click on it, and it immediately then in the code takes me to where January the 47th was put in. So I'm going to fix that. And now I'm going to do what's called a hot restart. Remember, we took 20 seconds before, and that took, according to what's down here, 1.9 seconds, okay? So what had happened on the original long startup is that it was loading the dark virtual machine, because when you're running in debug mode, you're using just-in-time compile, right, that had been developed before. So it had to load that machine, it had to start up the app, it had to make certain connections on the back end, and that's why it took so long. It only took 1.9 seconds in order to get back to here this time. Now, it's kind of a pain, right, because I now have restarted the whole app. I'm not seeing the fix that I just made, so I have to go back through this login to get back, but you can see that it's fixed. So 1.9 seconds to get back to starting the app, and I can see this change. Okay, so that's a good thing. However, it gets better, and this is the part that really is nice about it, and that is there's a hot reload where you don't have to go through all that. So you'll notice I've scrolled to where I can see this particular bullet point that I wanted to make, and now I'm already in the right place in the code because I found it before. So now I'm just going to change that text, just copy and paste something I'd already had. Okay, so that's there. Now if I hit the hot reload, by the time I get back, it's already done. Okay, so that took 800 milliseconds. So it's called stateful hot reload. And you can well imagine that if you're trying to develop a UI, then you can just really quickly tweak things, go back to the code, tweak, go back to the code, and do that. So this gives me a chance to pitch the Flutter OKC meetup. I'm starting a group for Flutter. With any luck, we'll meet here, but we'll meet somewhere. If you're interested and haven't already heard of it through the Meetup app, which actually most of you probably have, you can contact me at this email address, mdresserm@gmail.com. Okay. So let me go ahead through that. I should always say that testing is well developed. Unit tests, widget tests, integration tests, they're all available out of the box and as straightforward as testing can be. So in order to set up to use Flutter, basically you'll have to download the Android and iOS toolchains. You'll need an IDE, that is either Android Studio or IntelliJ or VS Code. And a lot of people favor VS Code. It's free, runs on all the different platforms, it's lightweight, but the plugins for Flutter are really effective. I'm using IntelliJ just for almost historical reasons, okay? And if you want to get started with Flutter, the best place to start is at the Flutter.io website, right? And you can navigate to get started there, and it will tell you everything you need to know in great detail. Stack Overflow is a very busy with Flutter these days, and everybody here knows about Stack Overflow. So that's another place to go for help. When I gave this talk in November, it was a week before the big Flutter coming out event that Google held. So as of that event, the stable version 1.0 is now available. Up until then, it had been beta, and before, when I first started using it, it had been alpha. And with that release, there are even more I/O components. And it supposedly is pixel perfect now on iOS. If you go to the flutter.io website, you can easily navigate to Flutter for iOS devs, and basically that will answer a lot of your questions. It draws parallels between what you're currently doing in iOS, how you develop in iOS, what the parts are, to make it easiest for you to gear up. And I will say it again, Dart is a friendly language. It is not a hard language. If you know Swift, then you basically can step into this and start developing right away. I've read people claiming that, well, within 15 minutes you'll be writing in Dart and you can just learn it from programming in Flutter, and that's all you need to do. And that's only true, I would say, in a small way, because like everything else, the better you know the language, the more you can do, the better things you can do. And there are layers to the Dart language. Okay. Oh, and one more thing. If you want to have an idea of what an iOS developer, what his experiences were when he went to Flutter, there's an article, you could find it by searching on porting a 75,000 line. Just Google for that, and I'm sure it'll take you here. The bottom line here is that, well, it was 75,000 lines to start with, written in Swift and in Objective-C. This developer thought that if he started from scratch, it would be 60,000. We all know how that works. With Flutter, it turned into 30,000 lines of code. And he had estimated how long it would take and was coming in under time, okay, which has never happened to me, I don't think, to come in under estimate, okay? So it's worth noticing that. All right. Another thing that has happened since, well, in December and then since December, so recently, are embedders for Flutter. So there's already a Mac OS embedder so that you can run a Flutter app on your Mac. Windows is not far behind. Linux is not far behind. And if you know anything about Fuchsia, Fuchsia is Google's next shot at an operating system. It's supposed to run on everything from desktop to Internet of Things apparatuses, and Flutter is designated as the way to draw UI for Fuchsia. The thing that nobody saw coming, that nobody that I know saw coming, is a project called Hummingbird. And Hummingbird is Google's project to make Flutter run in the browser, okay? And I'm sure that that is leaning heavily on the ability to transpile into JavaScript, okay? So running in the desktop is basically underway. Running in the browser is underway. And for those of you that are harder core programmers like I am, they have announced, no, they haven't announced, but you can find it in their GitHub repo if you go looking for it, an FFI, which I had to look up. What is an FFI? It's a foreign function interface. So in this quarter, they're claiming they will release an FFI for C and C++ for the Dart VM, meaning that you can call to C++ code directly from the Dart VM. And they're aiming to do that also for the ahead-of-time compiled versions of Flutter apps, okay? And that then, even if they had not made it possible to embed things, or let me say it differently, to get your hands on platform-specific functionality, or to run things really fast, that should be possible in the next several months too. So it's sort of, I know, a big claim to say it runs on everything, but it's not too far off to say that it's Flutter may well run on everything fairly soon. Are there any questions about that part, that lead up? Okay. Yeah.
So what does integrating like third-party libraries look like in like maybe something that's already written in Swift or Objective-C? Is that doable, or would you have to find a Flutter equivalent?
Yeah. Thank you for reminding me to do that. No, he means me. The question is, what about third-party libraries? It's particularly something written in Swift, for example. Could you simply, I'm sure the question wasn't this naive, could you simply import it into Flutter? And the answer is, not that I know. Now, you, again, through that platform channel now, you can get to anything in Swift. So presumably you could have it specifically in the iOS part of your project and call it through that channel, okay? A little cumbersome. There are many plugins now available that already have the Dart side, the API, and the platform channel written for both iOS and for Android to do many of the things that you would like to do, okay? And for, I actually don't know much about Swift libraries. Swift hasn't been around all that long, but Dart certainly has a huge number of libraries that have built up and are getting better. And obviously you can use those libraries as well. Okay. Any other questions?
We've got a question from Twitch. For the Flutter group you talked about, do you have an anticipated meeting spot for that when it happens?
Could you say it loud?
Yeah, for the Flutter group that you mentioned earlier, the meetup, do you have an anticipated meeting spot for that?
Oh, well, I don't really. Apparently I missed the...
Repeat the question as well?
Yeah. And please remind me every time, because good, thank you. The question is, do we have a place already established for the Flutter OKC meetup? And the answer is no. I would do it here, but I'm going to have to find a sponsor. Techlahoma has already started their budget year, so it was too late to get in the door there. But as soon as I will find a place, and I'll let everybody know, certainly, the time and all that. And I've actually asked, and if you can, anybody here is interested, please let me know when you would not be available. We'll probably do a lunchtime, but I don't want to conflict with anything as far as I can avoid conflicting with anything that others might already have on their schedules. Okay. Anything else that I can forget to repeat? Okay. So, on to the more detailed things. One of the libraries that's available for to extend Dart function is RxDart, which is a ReactiveX extension. There are ReactiveX extensions for Swift, for Java, for PHP, for JavaScript, and all those are ways to essentially to put in streams that are chainable for object-oriented programs. If you don't know what streams are, I'll say a little bit more about it in a second, but what streams support is an observer and iterator patterns, and that'll become a little bit more, a little bit clearer in a little bit, and they're typically asynchronous. Yeah, I'll just move on. Again, interrupt if I say something that you think you should understand right at the moment, and I haven't. So, in RxDart, there are subjects. Subjects are observers, meaning that they can observe observables, which are streams. There are observables, meaning that someone else can listen to what's going to be admitted by the stream. And you can add new items directly to them that then will appear on the stream, okay? So, there's three types. There are published subjects, in Dart, but publish subject, behavior subject, and replay subject, okay? And I'm going to show you what the differences are, but what helps me is to remember this PBR acronym, okay? Now, I don't know how many of you are old enough to have been inundated with commercials for Pabst Blue Ribbon, but I was when I was growing up, and so this turns out to be handy because they're actually sort of gradations that go in that direction, so it can help you to remember it. Okay, so publish subject. what's drawn here, these are called marble diagrams. You'll get very familiar with them if you look into streams and using streams. But basically what it's showing is time moving from, along this arrow. And this particular published subject is going to emit a red, then a green, and then a blue marble. Below are subscribers that now want to listen to that stream. If an observer subscribes here, they're going to get each of those emissions coming out the stream, okay? If you subscribe later, you'll just get what has come along since you subscribed. So all the preceding events are gone, right? With a behavior subject, it's a little bit different. When you first instantiate it, you can give it a default value so that when someone subscribes, even if the behavior subject itself hasn't had, for example, in its observer role, some event come along or an emission come along, then the subscriber will get that. Then it will start to get the things that have come along from that published subject. If you subscribe later, after something has already been emitted, then you'll get the most recently emitted value, okay? And then every one from then on, okay? So it has a little bit more, it has a little memory and behaves a little bit differently than the published subject. And then the replay subject, again, takes that sort of one step further with its memory. And that is, if you subscribe early, you'll, of course, get everything. But if you subscribe later, you'll get everything that has been emitted by the subject up to that point, and then start getting real-time updates, okay? So those are streams, and one thing that streams come with, especially from RxStart, is that a large number of operators, things that you can do while you have the data in that stream, to map it or to change it in some way, or to check for whether it's even something that you want to emit downstream, or to merge two streams together, okay? Or to add two things from two different streams so that you get this at the same time, okay? This sort of joined emission, okay? So we're going to use the behavior subject. I'll point to that in just a moment. A pattern that Google first pushed for handling state, local state, in Flutter is the block pattern. BLOC is business logic component. And the idea is, and this is clearly a popular approach across for all platforms, is to get as much state out of the UI as you possibly can, right? And so block is a way to do that. And it uses these streams, and I'm going to demonstrate all this in just a little bit, but I should point out that once you have the information in that block, or a request to the block for information, you can also move out of sort of that local state and make API calls, connect to the network and so forth. And I'll show that again in a moment. So again, block pattern really leans heavily on RxDart for the streams and their operators, but also in Flutter, there is a widget called a stream builder. The stream builder actually listens on a stream, and every time something is emitted on that stream, redraws the UI. Okay, it's basically that simple. Okay, so there's one question is, how do you get access in a big widget tree like the one I showed before to a particular piece of state or a service? In Flutter, there's a widget called Inherited Widget that, as the platform is building a tree, if it encounters an inherited widget, then it puts a reference to that in a table. So the way this is set up with this inherited widget at the top, and here we're going to use it for a block provider, then any of these widgets below it can easily get access to that provider. and I'll show you the code for doing that. It's actually pretty simple, and it's very fast, okay? The idea of this block provider is to provide a block, surprisingly. So here it is. I don't know if you, yeah. This block provider inherits, it's a subclass of inherited widget, which provides that nice sort of incorporation into the framework when it's first getting built, provides a block component using this stream builder widget. Then it can send data to the block, and it can get data back from the block, okay? So it's a two-way thing. All right, so let's look at the provider just to see sort of what that would look like. And it's actually very simple. So first of all, let's see, I had it in the tree, but to give you an idea what that looks like, here's the app itself, which is in fact a widget. All the widgets, well, many of the widgets have build functions. So what are you going to build to show on the screen or to handle what you're going to show on the screen? So in this case, it has a login block provider, followed by a goals block provider, followed by the material app, which just gives you access to material, well, to a lot of functions, including material widgets. You can put Cupertino widgets in if you want that functionality and look. And then home is actually a different name for a child, so it holds a scaffold. And then body is actually the name of a child within a scaffold. And then we finally get to the login screen, which is, and I'm just going to go ahead and restart the app so that we can see it. Okay, so here's the login screen where you can enter an email. Oh, and I didn't say this before, and that's why I put it up here so I would eventually remember. This is from a Firestore demo app written by Sager Surrey. Okay, so where you can enter the email ID and enter a password, and you have a submit button. It's fairly straightforward, right? So that login screen is right here, and it sits at the bottom of this widget tree, right? The app, the login provider, the goals block provider, I'm not going to deal with that now. The app, material app, the scaffold, the login screen, okay? But since the provider's above it in the widget tree, then we can get to it by, go to the sign-in form. So this is a sign-in form widget. Actually, it's the state for the widget, which is here. The state part of the widget is going to hold this state, the block that we're interested in. And in this method that's called early in setting this up for the screen, we call login block provider of context. So the question would be, where does that come from? Well, it comes from here. This is the login block provider. Extends inherited widget, right? When this is instantiated, it instantiates the login block. We're going to ignore this for the moment, but here's that of method. It's static, so it's always available as long as you have an import that gives you this login block provider. And so simply by calling it and calling it with this context, which says, basically places this widget in the tree somewhere, okay? Then it's going to return the login block provider block, okay? So you have access to this block, this particular login block, anywhere, since it's way at the top of the tree, anywhere in the app, okay? And again, if you have questions or if I've gone too fast or anything, by all means, slow me down. Okay, so that is the goal there. So how are we going to use this block? The way it's used in this app is that we have this login screen sign-in form that the user can see. It's going to use the block essentially as a view model or presenter, or there are other things that go in this layer, right? Anything that you may have used at this layer. And I'll point out one more in a second. The block, and I'm not going to go into this, but in this case, the block would can talk to a repository, and I like the repository layer myself. And then the repository talks to network providers, database, the file system, and that sort of thing. So this is actually how you get sort of out of the local process, out of your app, local code. Now, anyone that heard the talk that I gave at the end of November, this might look similar to middleware for Redux. Now, Redux is a very heavyweight way to handle app state. There's a fair amount of boilerplate with it, but it is incredibly extensible. It really simplifies how you think about things. There's a Redux plugin, or actually several Redux plugins for Flutter. And in that, there's sort of, it enforces the sort of this, I think it was Facebook, their flux flow of data, right? So it's a one-way flow of the data to handle the state. Middleware is where where an action can call out to the network, okay? And so block actually can serve as middleware, and there is at least one implementation, maybe two, of Redux that uses blocks as the middleware. And that's, many of you probably don't care about that, but for those that do, it's there, okay? So we now, sign-in form now has this block, which we, via this of, static of method, and it's going to build, because it's going to, and return a widget. It's a widget itself, of course. These things in a column. That is, so column is a widget. It's going to be centered. It's going to build this email field and the password field and the submit buttons. And those are other methods within this same module. So we'll just go straight to the email, and it's the only one that I'm going to deal with because there's not enough time to do it otherwise. So in the email field is a stream builder. Okay, so it's going to listen to whatever's emitted on this block email stream. Anytime the text in the text field is changed, it's going to send that text into the block using the change email method. Okay, and I'm going to go to those next. So basically, you change the text, it's going to send it out to the block to deal with it. If the text is changed in the block's email, then that's the stream that comes in, and it will be updated on the screen. And one other thing, I really won't go into this, but you can handle errors, and that's another really nice thing about streams in general. That is, they're monads. They pass a lot of context along with them. Okay, so, and you can get back errors, or usually you can get back either the data or an error or basically a stop. That is, nothing more should be received from this stream, or should be listened to, whatever. Okay, so let's go to the block. Now I have to explain a little bit more about Dart syntax here, but what we're going to be talking about specifically is this, is this email behavior subject, okay? So it's a behavior subject. The data that's going to be passed, the items that are going to be emitted are strings, okay? Since it's a behavior subject, you can either add things to it, so it'll come out the other end, or you can listen to it. Again, it does both of those things. So first, how could we change the email? And I'll go back and remind you that that is what's going to get called anytime the text in this field has been changed, anytime the user types or deletes or whatever, okay? In Dart syntax, this email, I should point out one thing about this, or two things. Final means that it's immutable, and this underscore right before the email, this, right, means that it's private. So the only way you can get to it, it would be with getters or setters, right? It actually is very handy. So for the change email, it's a method, right? It's going to return this function. So as a subject, you have a sync that has an add function. So anything any string you submit to that add function is now going to get emitted by the stream. Okay, it's how you add it into the stream. Is that clear? And this is where having functions as first-class citizens is very handy. All right? What if you just want to get the email? And so I'll go back to here. Again, this is what the stream builder is listening to in order to put it in this text field. All right? You're going to get the email. So you'll notice that the thing here, the syntax here is just block.email. So that getter is, you don't have to say get, you just use the email. In this case, it's returning the observable, because that's what we want. We want to know what the email text really is. And here it's returning the email stream. Okay, and that's what we want. We want to listen to that stream. But there's another point here, and this gets back to what you can do with streams. That is, while you have the data in that stream, and it's not really state at that point. It's not obvious to anything. It can't change anything outside the stream unless you explicitly have it change state outside the stream. It's going to call this transform method. So what's this validate email? Okay, so basically things are going to come in to the stream. They're going to, that string that's getting passed, emitted by the stream, is going to get passed into this stream transformer, which is going to take a string and return a string, and it's going to use this method when it has the string put in, and it'll return whatever's here. Now in this case, it's not really returning the string so much as, and in fact it's not, it's just going to pass it through because it's not going to change it. What it is going to do though is see whether that string contains an @ So you'll recognize that as a very poor check for an email, right? But this is where a validator would go, and that's really all he's trying to do here. And if it has an @ then it's going to add that email to the sink. So now that will come back into show up on the screen. Okay? So we've had a chance to check whether it meets particular qualifications before we actually make it, we pass it through so it can be emitted by the stream. If it doesn't, then we add an error. All right? So let's go back and sort of look at that. So here's the text field that we're talking about. If I start typing, this is that error message, enter a valid email. Okay? And as long as I don't enter an @ then it's going to continue to do that. If I go back and enter even just an @ because this is a wonderful validator, then it's fine with it. Okay? And the same thing is going to be true with the password, where really it just checks for more than 3 characters. So as soon as I do that, we're ready to submit. Okay? As long as you have access to this block, then you have access to that email, and that can be passed on, as I said, to other places. And that basically is what it's doing. It's going to go to the repository, which is then going to forward it to this back end now that it's been validated locally, and do all the things that we've seen. Okay? So just to sort of summarize what all that was about, that by using subjects, RxDart streams, but specifically the behavior subject, we can link this block, that is this business logic component, to a stream builder and just basically sort of do anything you want to do as you're entering that data, do any validation you want to do, send it out to the cloud somewhere, get it back via the repo and then the block, and update the UI that way. And it's a very powerful pattern because none of this logic shows up in the UI, right? The UI is basically stateless. It has to, in this case, keep the reference to the block, but that's it. And you're not frequently not concerned about that as state that you need to maintain, right? That you would need to persist or whatever. Okay, so just again, to sort of summarize the whole thing, Flutter's here. It's going to run almost everywhere if Google's plans sort of hold true and pan out. And I don't know any reason that that shouldn't be the case. It's really fun to program in. I highly recommend that you just go through flutter.io, right, and go through the setup. There is a fair amount that you have to do if you want to do, if you want to develop on both platforms. You have to have Xcode somehow. This group, that's not going to be a problem. If I talk to Android developers, that's going to be a problem probably. You're going to want Android Studio. There are, as there always are, a lot of little nitpicky things that you have to do, but there's plenty of help. There are now plenty of videos out how to set up and the details there. There are a lot of really good resources in terms of articles and videos for how to do these things. So I hope some of you will give it a try. I hope some of you will show up for the Flutter OKC meetup. The goal for that is that if you're a beginner, you're welcome. If you're an expert, you're maybe especially welcome by me. Well, I learn by teaching and I learn by being taught. So I'm in the middle, really. That's, you know, I love to teach because then I remember it better. I love to be taught because I sure don't know it all. So please show up. Any questions that I will repeat? Maybe. Nope. Yes.
Is there like a package manager for Dart?
There absolutely is, called Pub, and it's very friendly. I told you I would. The question is there a package manager for Dart? And yes, there is. It's called Pub, and it is very simple and easy to use. In fact, when you first set up a project using whichever IDE, or you can actually do Dart Flutter development from the command line and just with an editor, but I wouldn't necessarily recommend it because it's so easy. These IDEs are free, so I would take advantage of them. But when the project is first set up, you have a so-called pubspec YAML file where you list all of your dependencies. Okay, so this line is saying, I want Dart that's greater than 2.0, and you do. All various libraries, built collection and built value are generators to build immutable classes for you, and they also automatically build the equals and hash functions for you, so that's nice. And they provide builders so that you can, I won't go into that, it's too late. Cloud, Firestore, image pickers, RxDart, and so forth. And you'll see these version numbers. Different people, I think, see these things different ways. I like to have a specific version number, you know, listed because of, then I have to go in and update a version, and then if it breaks, I know that that's what did it. But in fact, you can just leave that blank, and the framework will go look for versions that are that are consistent with one another, because many of these libraries depend on other libraries. So it handles all that for you. And so what I do, if I have a problem or if I'm using a new, well, no, usually if I just hit a problem, what I'll do is delete the version number, run it, and then you can go to the pubspec lock file and it tells you what version it's settled on, and then I can put that version in by hand. And that way everything works and I get the opportunity to update the way I like to update. Big long answer, but it's handy. It really helps. Any other questions? Yes.
How does it deal with like all the messy stuff in Xcode where you're managing your capabilities and stuff for say Apple Pay or push notifications, all of those details, where you like that would get you ready to submit to the Apple, you know, or that last mile kind of stuff?
I heard so, okay, so I'm not going to repeat that question because I need you to narrow it down.
So suppose you need to configure your app for push notifications
Right,
for Apple.
right.
The
There's a plug-in for that. The question was how you handle push notifications, if you want push notifications, because that's handled, in fact, deeper in these platforms, and there is a plugin already available for doing that. In Android, you have to worry about permissions a lot, and there's a plugin for handling permissions, which is handy because that can be very tricky. But yeah, and most plugins that are out there now are, in fact, dual functional. That is, they work for both iOS and for Android with basically a unified API. Some are still separate, and there's a couple of things that I thought I might take on, but I need an iOS developer because I don't want to put out a plugin that's just for, you know, one of the two platforms. Sir.
We got two questions on Twitch. First one is there a way to write unit tests for Flutter?
Absolutely. Well, unit tests, the question is, wow. The question is there a way to write unit tests? And the answer for that is absolutely. Since it's a unit test, you would be writing it in Dart, not Flutter, because you don't need a framework for unit tests. And there is indeed a good harness for that. Also, for larger scale things where you do need Flutter, where you need to set up a widget by itself, you can do that for widget testing. And of course, for integration testing, there are a number of ways to step through, you know, to launch the app and then step through it. And the second question?
Second question is, can you build or develop for the browser, or is it like React Native where you need the iOS or Android emulators?
So the question is, can you build for the browser? And by that, I think you mean so that it runs in a browser?
Yeah, I think to develop using the browser, so you don't spin up an
Okay, so it was really two different questions then. Well, one is, can you develop using a browser, or do you need an emulator? I honestly don't know if there are any web available build tools like that. You certainly don't have to have Xcode in order to develop for iOS, because you can use a service to do that. And a lot of these continuous integration, continuous delivery systems can handle that. There's one in particular that Google has promoted, and I cannot think of their names right at the moment, but yeah, there are at least 3 different CI/CD services available out there. As far as running in the browser, then again, that's that Hummingbird project for Google, where the goal is that you should be able to run Flutter apps in the browser. Does anybody think I should have answered differently or more? Because I will try. All right, if there's no more questions, I appreciate it.